Good morning students. Today we are going to learn about how to write the VHDL program for T flip-flop with the reset and without reset. Okay. This is the VHDL code for T flip-flop without reset. Okay. Here there is no reset signal. Okay. In T flip-flop we have only one input and two outputs. Q and Q bar are outputs. T is the input. Clock is used to activate the flip-flop. Okay. In T flip-flop, when T is equal to 0, then the output will be the same as the previous output. If T is equal to 1, after applying clock pulse, the output will be the complement of the previous output. Okay. This is the VHDL code for T flip-flop without reset. Okay. In every VHDL program, we have library, entity and architecture part. Okay. This is the library part, this is the entity part, this is the architecture part. Okay. In the entity part, all of you know that the first line is entity name is. Okay. In this program, entity name is T flip-flop, behavior is the architecture name. So, entity T flip-flop is. Next, I am declaring input output ports of T flip-flop. Okay. Here, T and clock are inputs, Q and Q bar are outputs. Okay. So, T, comma, clock, colon, mode in, then STD logic. STD logic means standard logic, semicolon. Next, I am declaring output ports Q, comma, Q bar, colon, mode out, then STD logic. STD logic means standard logic. Okay. In the third line, you have to write end entity name. Entity name is T flip-flop. So, end T flip-flop. Okay. Next, architecture part. In the architecture part, we know that the first line will be architecture name of entity name is. Okay. In this program, T flip-flop is the entity name, behavioral is the architecture name. So, architecture behavioral of T flip-flop is. Okay. Next, you have to write begin. Okay. In this program, I am using if statement and process statement. Okay. Here, process, open the bracket, T and clock are inputs, T, comma, clock. If any changes occurs in the T and clock, then it will execute the statements inside the process. Okay. One by one. Here I am declaring temp as variable. Okay. So, the syntax for variable declaration is first you have to write variable, then variable name, colon, type of variable name. Okay. So, variable name is temp. So, variable temp, colon, STD logic. You can use bit also. Okay. Temp is a binary value. Either it can be either 0 or 1. Okay. Here I am using STD logic. You can use bit also. Okay. Bit, BIT, bit. Next, you have to use begin. Here I am assigning the value 0 to the variable temp. Okay. So, temp, colon, temp is the variable. So, you have to use colon equal to. Okay. Please note it. In signal assignment, you have to use less than equal to. In variable assignment, you have to use colon equal to. So, temp colon equal to 0. So, 0 is assigned to the variable temp. Okay. Now, I am checking the clock. Okay. In T flip-flop, if T is equal to 0, then the output will be the same as previous output. Okay. If T is equal to 1, then the output will be the complement of previous output. So, first I am checking clock. If the clock moves from 0 to 1, then it comes to this statement. Okay. If it is not true, then it comes to here. Okay. So now if the clock moves from 0 to 1, then it will check the value of t. If t is equal to 1, then temp is complemented. The complemented value will be assigned to temp. Okay. Here you see, if t is equal to 1, q is equal to q bar. Okay. So now here you have to write temp colon equal to not temp. Okay. The complement of temp will be assigned to temp. Okay. Now I am closing this if statement. So end space if. Okay. Here I am closing this if statement. So end space if. Now I am assigning this temp value to the output q. Okay. So q less than equal to temp. Q bar is the complement of q. So q bar less than equal to not temp. Okay. Here I am closing process statement. End space process. In the last line I am closing architecture. So end architecture name. Architecture name is behavioral. End behavioral. Okay. This is the VHDL code for T flip-flop with reset. Okay. The same program, just I am including reset statement. Okay. If reset is equal to 1, here you see we have library part, entity part and architecture part. In the entity part I am declaring input and output parts of T flip-flop. Here I am using additionally reset. Okay. T clock reset are inputs, q and q bar are outputs. Okay. Here also you have to include reset. T comma clock comma reset. Okay. If reset is equal to 1, then temp is equal to 0. Okay. First it checks the value of reset. Okay. If reset is equal to 1, then the value 0 is assigned to temp. Okay. If this condition is not true, then it comes to this else statement. Okay. Now it will check the clock whether it moves from 0 to 1 or not. Okay. If the clock moves from 0 to 1, then it will execute the following statements. Okay. If it is not true, then it comes to here. Okay. Now after checking of clock, if the clock moves from 0 to 1, then it will check the value of t. If t is equal to 1, then not temp. That means the complement of temp value will be assigned to temp. Okay. Here I am closing this if statement. Here I am closing this if statement. This end if is for this if statement. After this, now I am assigning the value of temp to the output q. Okay. Q bar is the complement of q. So q bar less than equal to not temp. Q less than equal to temp. Okay. Here I am closing process statement. So end process. Here I am closing architecture. So end architecture name. Architecture name is behavioral. Okay. So end behavioral. Okay, thank you.